Hello Year 10 and welcome to another week of home learning. We are kicking off a new topic, the final topic for this year for you, which is, as you can see, to do with waves and wave properties that we're looking at this week. This will take us all the way through to the end of this half term. So I'm just going to go through a short tutorial on some of the tasks for this week. You can access this PowerPoint at any point. It will be in Go for Schools and on Teams, and hopefully it will be nice and clear for you. If you do have any questions, please do let me know. Okay, so where are we? Right, first of all, start a task for you. Okay, I'd like you to pause the video at this point if you're using that, or stop the PowerPoint at this point and write down any types of waves that you can think of. Okay, all different types that you already know. Just make a list. There may be some that you know about already. There may be others that you haven't heard of. So just take a moment to pause and write that down into your book or in your notes. Okay, so I'm going to show you a few. You may have got some of these. Okay, ocean waves, waves in the sea, microwaves, which are a thing, obviously not just the things that you cook your food in, radio waves, Mexican waves, X-ray wave, sound wave, light wave, infrared, ultraviolet, gamma rays, gamma waves, and just a friendly wave. So hopefully you should have got some of those. Okay, now there is a video here which is loaded into the PowerPoint. There is also the link available to you there. I'm not going to play this video now. Okay, I'm going to allow you to play it when you go back and watch the PowerPoint yourself. Okay, but this demonstrates the two types of waves that we're talking about this week. Okay, so you'll see there's a short video there. Okay. Okay, once you have watched that video, you will have seen that there were some new keywords that were mentioned, okay, which I've listed here. So obviously wave, transverse, longitudinal, oscillations, and energy. And I'd like you to find definitions for each of those and create a table of them in your notes, okay, just a definition for each. So that's your first task. Okay, so I'm going to run through the two types of waves that we're really talking about, and I'm going to instruct you on what to do. Again, you can pause the video at any point, or as I say, you can go back and look through the PowerPoints in your own time. Okay, we're going to talk about transverse waves first of all. Here we have waves, as you can see, where the oscillations are what we call perpendicular to the direction of energy transfer. So what that means is that they go in an opposite, they go in a 90-degree angle. So the oscillations go up and down. If you notice the particles here, the little black dots are moving up and down, but the energy transfers from left to right. Okay. So I'll just give you a minute to view that. And I'd like you to draw very carefully in your notes what a transverse wave looks like. Okay, so you'll notice that it's a normal sort of wave kind of picture that you would are used to seeing. There are a few things that you need to label. Okay, so you'll notice the oscillations are labeled with the arrow going up and down. There is a wavelength. Now it's really important that you mark the wavelength from one point on the first wave to the exact same point on the next wave. Okay, that is the length of one wave. Then you have the peak and the trough. Okay, so the peak obviously at the top of the wave and the trough at the bottom. And in between that, you have something called the amplitude. And the amplitude is the distance from halfway, okay, up the wave to either the top, the peak, or the trough. Then you also have an arrow showing the direction of wave travel. Some examples that you need to note as well would be things like water, radio, microwaves. So all of these, most of the waves that we know about transfer energy as a transverse wave. Okay. So please make a note, make a nice clear diagram in your books of that and the examples as well, with it's clearly labelled. So the second one we're going to look at is the longitudinal waves. Okay, and here the oscillations are instead parallel to the direction of energy transfer. So what does that look like? If you pick one of the red dots that you can see, you'll notice what happens to that red dot. Okay, it moves right and left and right and left. Okay, so it oscillates left and right. Okay, but what you notice is that the energy, the movement of that wave appears to travel from left to right all the way. Okay, so here we're showing from a loudspeaker to your ear. Okay, so the way that that travels, the energy transfers through from in that sort of direction from left to right. Okay, it then vibrates and makes your eardrum vibrate. Okay, bounces around and allows you to form words in that you can hear, or noises or sounds or music or whatever. So a longitudinal wave. Okay, again, I'd like you to draw and label this. Obviously a bit different, okay, but the way we draw it is through a series of lines. Now it's really important that those lines are shown as I've shown them on the picture, because we have two parts to the wave. Okay, we have areas of compression, which are here where wave fronts are very close together, where those particles were very close together, and we have areas of rarefaction where the waves are spread apart, big gaps. Okay, again, the wavelength, the arrow is not very clear, I do apologize, but the wavelength going from here all the way to here, okay, is one wavelength. Again, showing that the oscillations move left to right rather than up and down, so parallel rather than perpendicular, and the direction of wave travel from left to right. Examples, really just two, sound and a particular type of the seismic waves that you hear that transfer during an earthquake. Okay, so make sure you have those two waves drawn nice and clearly in your notes. What I'd like you to do now, okay, is to draw yourself a large Venn diagram into your books or in your notes. Okay, and I'm going to display on this PowerPoint and the next slide there are a series of words and drawings, okay, which I want you to put in either the transverse or the longitudinal part, or in both. Okay, now some of it may not be obvious, some of it you may have to find out for yourself if you're not quite sure. Okay, but I want you to have a go, and I'd like you to send me a picture of your completed Venn diagram. So there's the words. Okay, some of them you may not be sure about. Okay, some of them may not be clear, but hopefully you will have seen enough from what we've done so far to have a go at that. Again, you can pause here and use that slide, or you can come back and use the PowerPoint. Okay, and then your consolidation task for this week is to complete the set of exam questions that I have again put onto Go for Schools and on Teams, and then please submit them, if possible, please submit them through Teams for marking. It does make it easier. If you are having problems with Teams, as ever, please do email and ask. Okay, and we'll see if we can sort that out for you, because it does make it a lot easier. Okay, that's all for now. As I say, this PowerPoint will be available, and I look forward to seeing how you get on this week. Have a great week.